let's talk a little deeper about wastewater. We did talk about ways to reduce potable water already in terms of installing low flow fixtures and toilets and being able to use recycled gray water. But there are other ways also to reduce wastewater, which can be one of the biggest uses in a residential application. There are many case studies of actually treating your wastewater right here on site. So we can either reduce the amount of wastewater in a building or treat it as well. So let's look at some case studies. The Bronx Zoo in New York City has been has a couple of installations of composting toilets. That means that it's collecting human waste in a regular restroom, and they're able to put it through these digesters, essentially being able to extract the nutrients from it to be able to use as fertilizer. And in that sense, none of the the wastewater is going to the municipal system. They're also being able to do this for some of the animal waste that they're collecting right there at the zoo. The Solaire is a building in Battery Park City at the very southern tip of Manhattan in New York, and they actually have a very high-tech on-site wastewater treatment. Now, this is a luxury building, and they use something that's called a living machine. A living machine was invented by a gentleman named John Todd, but essentially it mimics, it's a man-made process, biomimicry, if you will, because it mimics the way that natural wetlands will work. So it will capture wastewater and solid waste, and be able to move it into a whole series of different settling tanks. And through that, plants and different microbes are able to break it down so that plants can feed on it, and there's no smell. Here's a more detailed look, but the Solaire is using treated water. It's capturing it, it's treating it, and then it's reusing this water to flush their toilets and also cooling tower makeup. So, part of the way that a living machine they've got works is that, again, they have a settling tank. They have anaerobic and aerobic areas. And if we follow this slide, it's labeled. So number 1 is a place where the wastewater is collected, so into a tank. And then from there, it goes into number 2, a stormwater collected treatment. So it's also collecting wastewater and stormwater. Then it goes into number 3, this biological treatment area. Now these are normally contained in this stage, normally either underground or in big tanks, and then they're able to pass air through it to kind of aerate it, get rid of any kinds of smell that they're able to discharge. But what's left is being able to separate out the solid waste from the liquid waste. Then from there, on number 4, final polishing and disinfection. A lot of times, even before that, it's going to go through a series of the holding tanks with the plants and sometimes even fish and other microbes. Let's look at the next picture. This is a photograph. I believe this one is at Oberlin College, but these are the part of that living machine where the solids have already been settled and they're trying to now treat the liquid portion that's left. It's already been aerated, but now it can be used to feed different plants, and the plants themselves are going to start feeding out and filtering this water. Here's another example from, it's called the Sidwell Friends School. This is in Washington, D.C. They actually have a very intricate, not only waste but rainwater capture system. So for this one, they've got green roofs on the top. They've got where they're capturing rainwater. They're also capturing toilet water. If you look to the orange area on the right-hand side of the slide. And from all of those building uses, then they bring it onto, if you can see this loop-looking orange, follow the orange line, orange arrows, and it goes through this whole area where a biological pond. Let's look at that. Let's look at a photograph of that. So here's an up-close photograph of it, to where the water will go through a series of plant filtrations, and at the end it turns out clean. Now, it's not clean enough for drinking per se, but it's great for irrigation, to use again for flushing toilets. Sometimes you need it also in your HVAC mechanical systems for cooling. But so these are great examples of how we can treat wastewater and then use it again to create a closer to a closed loop water cycle. So speaking of plants, landscaping is also a really important thing for us to consider. We use a lot of potable water just to irrigate our plants. Often that irrigation is ineffective. Typical sprinkler systems spray water up into the air, a lot of it gets evaporated, and they're not put in a place where plants can use it. So one effective way to reduce the amount of irrigation water that we need is to use efficient irrigation. This is one example called a drip line. So this is essentially like a tape or a tube that has small little holes in it, and it lies, it lies underneath the plant and right at the base, and it can be laid right into the soil. It can even be buried into the soil. But the idea is that it will, when you turn on the irrigation, these lines get filled up, and the plant basically takes what it needs, and the water is delivered right there near the root, rather than, the other example where we saw a lot of waste happening. This one, we can really control the use. You don't need as much water, and the plant is able to make better use of it. Another strategy is using captured rainwater. It's fairly easy and commonplace to collect water coming right off of the roof, store it in a tank. You can even put a filtration system in your tank to take out those total suspended solids, and then being able to use this directly to irrigate your plants. We can get really high tech and use things like water sensors. I can't even tell you how many times I've seen an automatic sprinkler system going when it's raining outside, and it's the most idiotic thing in the world. Well, there are a lot of high-tech solutions out there where it's compiling weather data, so it knows, hey, it's going to rain in the next day or so an automatic system doesn't need to go on. You can also have sensors right there in the soil to test how wet or dry the soil is itself, and it will, sprinkler systems and different drip line systems can go on based on the actual need rather than just on a set schedule. But also the types of plants we use will really make a difference in how we can save water. By using native plants that are adapted to the local region, the idea is that these plants have already adapted to survive based on just normal rainfall in an area. So then you actually don't need any irrigation whatsoever. We've also got a movement and a practice called xeriscaping, and this is using extremely drought tolerant plants such as cactuses and also different succulents and also different types of native wildflowers to be able to to be able to construct landscapes that need no irrigation whatsoever.